Perfect. Last class, as always, we will work with some data today. I've pasted the link to download the data in the chat room. So if you go into the chat room, you will find the Dropbox link where you can download the data that we will work with today. And let me share screen here. Today in the fourth and last class, what we will do is, again, this is the kind of the schematics of a full data science project that we've been talking about all of these 4 weeks, basically. So again, just to summarize, we started the first class focusing on just making sure we can get some data into it, into R. We looked at how to visualize the data, so how to create plots. We also, in the second class, what we did was that we focused on transforming variables. So how do we calculate new variables? How do we summarize? So when we want to get the mean value for a certain group, or when we want to get the median with a standard deviation and so forth. So that was what we worked with in the second class. Last week in the third class, what we worked especially with was how to tidy the data or clean the data. So when we get data that is in another format than the one we actually want to use for doing our analysis, how do we merge data? So how do we join data if we have several different data sets? How did we looked at pivoting? So if we have data in more columns that we are interested in, how do we get that data into the same column? We also looked fast at how do we get if we have too many rows. So there is some values that we want to get that is currently in the same column that we want to get into different columns. We also looked a little bit on how to save your plots and how to save your, if you create tables, how to save them into a CSV format, which then touches on this part, which is how do we communicate our analysis. So what is left to actually dig into a little bit deeper is the first step. So how do we actually import different type of data into R so we can start to work with it? And we've been working with, for now, we've only been working with the CSV files, so comma separated values. We'll dig a little bit deeper into that, and then we will check a little bit how we can do if we have data in other formats. And again, just a reminder from last week, when we talk about tidy data, so when we clean the data and want to get it in, we want to get it into a more or less standardized format where we have columns in our data frame that represents the different variables, the different type of measures that we are interested in looking at. We want to have one row for each observation. So remember that what counts as an observation can differ depending on what type of analysis you're interested in doing. So it might be that we want one observation per athlete, but it might also be that we want one per day of each athlete. So if you want training sessions, for example, if you want to analyze training variability between sessions, then what we will want is to have each training session or each training day on a separate row as its own observation. So again, just what constitutes an observation will depend on what you're actually interested in looking at. And sometimes that might change throughout the analysis as well. So then you might want to go back to the two pivot functions, so pivot longer, pivot wider, to transform, because it might be that you at the first stage are interested in, let's take here if we talk about a team sport setting, it might be that you've done some physical tests with a team before the preseason start, at the end of the preseason, and at the middle of the season, right? So you have 3 time points. And so what we're probably interested in doing then is to have 1 observation per athlete and measuring point. So athlete 1 at start of preseason, athlete 1 at end of preseason, athlete 1 at middle of season, and so forth. So this would be what we want to have as observations if we want to check, for example, how much did it change? So how big improvement did we see during the preseason? But it might be that we also, apart from that, want to do some analysis just comparing. So was there a difference at the end of the preseason between different positions? So did the strikers, if we're talking about a football team, how did their values differ from defenders? And then we might want to have 1 observation per row, which in this case would be athletes then. So that might vary. And then again, when we talk about a single cell, so 1 column, 1 row, here we're talking about a value, right? So each observation will have a value in each variable. So just the variables, when we talk about variables, we talk about columns. When we talk about observations, we talk about rows. And when we talk about values, we talk about cells. This is just to remember how we use the terminology. Today then, we will look at these different ways of working in getting data into R. We will repeat a little bit about comma-separated values, so the ones that are called CSV files, and we've already used the readr package to read them. We will look at a little bit different cases where, for example, a comma-separated value, so where we separate the different columns with a comma, and then we use a dot to denote decimals. So we have 4.3. It's actually a 4.3. That's the American standard of doing things. In Europe, for example, it's much more common to use a comma to denote decimals, right? We would probably write 4.3 to denote the decimal value. So then we can't really use a comma as the way of separating the columns. So you might get CSV files that has the same ending, but then has a semicolon instead of a comma. Then we need to be able to know how to handle that. We'll obviously look at how to import data from Excel, because it's for better or worse the main way of storing data. We will look a little bit into how you can do if you have an SPSS file. So if you might get some data more so in research settings. Someone might have had some old data or collected data inside SPSS. This will work the same with a couple of other statistical programs. So I will show how to do it with SPSS files. It's very, very similar if you would happen to stumble upon a SAS file, for example, or similar programs. We will look a little bit on how can we actually just create data frames directly in R. Sometimes it might be that you just have a little bit of extra information that you need. Let's say that we have a nice data frame that we've imported with training sessions, and we just want to add some kind of information on the athletes that we know by head. Sometimes then it might just be easier to do that directly in R. without actually having a file to work with. And last, we'll look at JSON files. So JSON files are used a lot on in web development. So when we kind of need to transfer data on the web, there's something called an API. So when you want programs to talk directly with each other, this is often the format that is used. It looks a little bit different. It's hierarchical, so you have lists within lists. So that will look a little bit different. But that's the part we're going to get through today. So we'll get this out. And as normal, we'll start up same way as always. Let me see here. And we'll do here, we'll get started with the so you see my shortcuts as usual. And before we do that, we'll transfer this one over here. And here we go. Sorry, it might have been the case if I posted the link pretty early. So it might have been if someone didn't have time to get in yet. But everyone's able to get the link now with the data. Yeah, perfect. Good. So same as always, we get started the same way. We open R, we create a project so we know where we're working. Today, we will work specifically with importing data. So we might as well call it that. Again, the data that you will find in here is 5 data files that basically show the same thing. So it's the same data in 5 different formats that we'll work with. Same as always, we want to keep everything ordered here. So we put it into a subfolder where we drop the data. So now we have it here within our project, same as always. And again, first thing we'll look at is the CSV file. And if we actually look at how a CSV file looks like, so now I just view file. So I open the CSV file here. We're not in an R script or anything. We're just kind of looking at the data itself. This is how a CSV, a comma-separated file, would look. So you would have hopefully a first row with the column names. If you don't have column names in the first row, then you will need to know the column names from another place. But for now, we're focusing kind of on first row are the column names. You see here again, we have a comma to separate. So we have athlete name, it's one column. We have sex, it's one column. Test date, weight in kilos, and squats in kilos. We can see here that is strength tests. So we might assume that this is test of one repetition maximum squats. We check next row and we see the same pattern here. So right, we have first column, Amanda Smith, so athlete name, right? Female corresponds to the sex. Test date, here we have the dates, we have a weight, and we have the kilos that she managed to squat. So as you see here, the columns don't necessarily align because they're different widths. So if this one starts to get really big, it's hard to actually just open the file, look at it, and kind of get anything out of it. But again, this is how it looks. Short note, you see here, if we see 2 commas in a row, that means that the value here is empty. So again, we have athlete name is the first value, right? The sex is the second, the sex of the athlete. Next one is test date. Next one is supposed to be weight, but here we see that it's empty. So we're actually missing the weight for this athlete at this test moment. And then we have the squats, the kilos of squatting. And again, each line is one row when we work with the data frame. So you know that next row starts when next row starts within the file. So again, we want to get this into R. We create a script here that we probably will want to put in a folder that will in the raw data folder. Sorry, my fault. We'll create several scripts to work with importing the different types of data. So one tip of keeping a little bit of order is actually using some kind of numbering system. So the scripts will show up in the correct order. So here we'll have kind of we can import CSV. Again, we need to import packages. And here we remember that is the readr package that we'll use. The readr is the one we work with when we work with CSV files. And again, we want to read the data. And same as always, remember we want to save it into some kind of object like raw data. We could even be a little bit more specific here, raw CSV data. And then again, here we see that the read underscore CSV don't show up. So we have this other version that works as well. This is if we go to the help page here, sorry, forgot to start this one. Okay, now let's see here. Yeah, that works. If we go to the help page of this function, we see that it's part of the utils package. So not the one we're looking at currently. It's not the end of the world, it works as well. But since the one we want to work with now here shows up, so just again, remember dots and underscores are not the same. Same as capitals and lowercase letters are not the same. So you can have functions that look almost the same in the name, but there is a difference if it's a capital letter or not, so forth. Again, remember that we start counting from where the project starts. So from here in the file system, we need to go into the data raw folder. And inside here, we wanted the one that is called strength tests.csv, right? We read it, we get it here, and we can just have a first quick look at it down here. This is such as you see, since we're working with just 4 rows and 1, 2, 3, 4, 5 columns, 5 variables, this is small enough to actually show us everything here in the console if we just print it. So maybe not as needed to go in here, check the variables, click on it to get it up here. We can do that, absolutely. but we can just also print it here. Okay, two problems in this file. First of all is, remember that we talked about how do we want to name variables within R, and we said it needs to start with a letter, it can't start with a number. We cannot use space, we need to use underscores or dots or whatever we choose. And then we go in and look here at the names, and this is not true. We have special characters, parentheses, we have spaces, we have big letters, that works, capital letters, that's not a problem though. And the thing with R is you can actually use these names. You can have variable names that looks like this, but you will see always when there is a space, when there is special characters, that you have these backticks surrounded it. So when you import data from something that have variable names that include spaces, includes weird characters and everything, it will probably look like this at first. You can work with it this way, but it's much, much easier to actually make sure to transform the variable names into something that R plays nice with. So remove spaces, remove special characters, and so forth. And there is actually a short, quick way to do this very nicely. And for that, we will need another package. We will load a package that is called Janitor. So it's actually made for doing kind of small cleaning jobs as a janitor, like help to clean up. We need to install it first. So again, first step is install packages. When you install packages, you need the quotes, the quotation marks. Janitor, we install this. We see everything doesn't look anything. We don't get any errors or warnings. We'll just see download this from this place. The packages in this place. Okay, perfect. It worked. So now we can just load this package up. And the function that we will use is we use the pipe, remember? Push the data frame into the first argument within the function. And the function we'll use here is called clean names. So we want to clean up the names. If we just look at the help page, talks a lot about, because here you have a lot of options of how you want to work with different characters, how you want to normalize them and so forth. But at the end of the day, the only named argument and the named argument, so not everything that goes into the three dots, tend to be the important. So that is the data frame. Perfect. So if we just run this now, we'll see that we get standardized names. So names that works well for R to work with. So if we just compare here the original, this is how it was imported. And now if we clean the names, this is how the clean names look. So we can see here what it's actually doing by default is take away capital letters, make them small, change spaces for underscores. Again, here we see no capital letters. No capital letters, take away the space. It removes all the special characters. And so it just removes them, and same here, we get underscore instead of space and so forth. So now we have data frame with names that are much easier to work with us afterwards. We could obviously do this in in a separate step. So we first load the raw CSV data. Now we create a new object to get in with the clean names, but we could also just do this directly on the raw data that we import. So we directly in the first step read the file and fix the names. So if we run this now, we'll see that already the raw CSV data object, the data frame, has nice names to work with. So this was the first problem for us. The second problem, if we again go back and look at the data, is we see here, we remember that in weight, we had missing data, right? So this value was empty. Remember, the second row of data, not including the variable names. Second data, we had nothing filled in under weight here. And this works good, we see. NA was, capital NA was the way for R to denote missing data. So that worked well. The problem is if we look at the next row, we see that where is supposed to say weight, we have N/A, which is another way, especially in some other programs, to denote missing data as well. The problem here is that R doesn't recognize this by default as missing data. So what it did, it said, this looks like a character, so we have text. So this is just a text string that could say, weight, too little, a lot. This is not so nice to work with because we can't actually do. So, for example, we might want to calculate what is the relative. So what is the one repetition maximum in relationship to the athlete's weight? So then we actually need a weight in a numerical format, which we don't have. And again, this is supposed to be missing, right? We know that, okay, from the program that we got this out from, or from the convention with the guys working with putting this data in, we know that when they write N/A, that's missing. Or we know that when they write whatever they do, minus 999 is sometimes used as well. So all these, I wouldn't say weird, but all these different ways of denoting that we're missing data, we want R to actually understand that this is missing data. So what we need to do now is we need to go into the function, the read as CSV function. And if we look at the help page here, again, remember F1, we see that there is actually, if we go down to read CSV, we've been using this one, right? The file argument, which is the first. But here we have a lot of different arguments that we can use. You can dive into them and look. We can define the column names. We can try to define directly which type of variable the different ones are. Right here, it just guessed. It guessed that this is text. It guessed that this is text. Guessed that this is a date. So in this case, it guessed well, but it might be the case that you actually need to tell the function that, no, you're reading the data wrong. It shouldn't be that. It should be another kind of data. But the one we're going to look at now is this one. So again, NA looks like we're on the right path. Here we see that the default, so what it gives this argument if we don't put anything in is a vector of nothing, right? So it's quotations to say that we're working with text, but there is no text in between. So when there is nothing, that should be missing. That should be an NA. And if it says NA in capital, that should also be missing, or an NA. So here we can directly see that we don't have, so we had the empty one, right? The empty one was counted as a NA, or but we saw that this one n/a is not included here, so it doesn't. That's why it doesn't recognize it as missing value. So now we can actually go in and change this here, and start to customize how we want the read CSV function to read the data. So just to show you here, for example, if we would have put NA and only have N, if it says NA in capitals, that's the only thing that should count as missing data. Anything else, no. So again, by default, if it's empty, that's missing data. We say, no. Only if it says NA in capitals. So if we run this now, and we look at the data, we run this and we see, again, now the second row here where it was just nothing is not counted as missing data. We don't see the red NA in capitals. Here is just an empty cell, right? So now we just did the opposite of what we actually want. We removed something that we want to count as NA. Again, if we put just nothing in and run this and check, now we see we're back to this actually counting as missing data, which we want, obviously. So we want this one to count as missing data, but what we want to do is we want to add a second part to the vector where we say that anything that is n/a should also be counted as missing data. So now we're saying, okay, we want to use the read CSV function. We want to read this file at this place. And we want every time you see a value that is empty, like just nothing, or any value where you see n/a, count that as a missing. And we look at it, and now we see that both of these ones are the same. So now they are missing the way we want them to be. So again, oftentimes when you get different type of data in, you need to look into the data a bit to see, okay, how did they actually code the missing data? Did they use -999? Did they just leave it empty? Did they write NA in capitals? Did they write NA in small letters? Did they write n/a? Did they use something else? So you need to probably go in, look at that, ask if you can, and otherwise just go into the data, look at it, see what seemed to be missing, and then you can explicitly state it inside the function. A good tip that sometimes work for finding out missing data is if you have a column that should be numerical, so what is called a double, or num for numerical. So if you know, for example, weight should be measured in, it shouldn't be measured in text. The weight should be measured in a value, a decimal value or an integer value, but a number, not text. And again, if we take this out and we run it just as we did in the beginning, and we can either look at, after we run it, we get some information. We see here that, okay, 3 of the columns were text. So athlete name, that makes sense, sex. But here we can see the weight was text. So this is a could be a good indicator that something's up here. And probably the case is that it's how the missing data is coded, that they use some kind of text, because as soon as it finds text in the column, it will say, okay, this column is a text column. So again, you can see here that now it says character for text, because here it found text. So when you see this, this is when you definitely should take a look like, okay, is there anything in here that should be a missing value? Which in this case, okay, m/a, we add it, we run it, and now we see, perfect, it's double. It's numeric now, is a number, so perfect. That's a good way to solve that. Or sorry, that's a good tip to kind of try to identify that. Another issue that might arise when we work with CSV files is what I said, that there is difference between different regions of the world and how do we count a decimal, right? What is which character do we use to denote decimal? So here you can see 65.3, and if we look in the CSV file, we see again 65.3. So we use dot for decimals, and then we can use comma to separate the columns. Let's now say, let's restart again. So we start fresh. And if we now say that we want to create a new R script, we call this do want it inside the data raw, and here we want import CSV semicolon, for example. So if we want to do the same thing, so we just copy this again, read the libraries, and now we see here that in the data we had another data set that was strength test semicolon. So if we now instead try to import this data set, strength test semicolon, we can skip the cleaning names for now. We try to import this, and we see that we get a warning message, right? So again, we see warnings, we see errors down here in the console. Stop, take a look, read, see if you manage to understand what it means. And if we look here, we see, okay, delimiter, so what delimits the different variables, the different columns, a comma, right? And then we see here, and we see that there is actually only one column, one variable, and we can see it here as well. We only have one variable in the data. We know that there should be more. We know that there should be 5. So something's up, something's not right. And we can actually see, because if we look at, these were the different names, and the function expects it to be a comma, right? Every time it's a comma, separated into a new column. But we see here that it's actually a semicolon instead of a comma. So this is actually the major problem. We could call the problems function on this and so forth, but in this case, we've already detected the problem. And that's actually, so if we go in and look at this file, so view file, we have the old file here, and we have the strength test CSV file here, and the one with semicolon we have here. And if we just jump back and forward, we can see that, okay, here we had commas, we had dot for decimals, and here we have semicolon, and we have the comma for our decimals. So we need to work with this in another way. And the quickest and easiest way to do this is if we go into the help file, we see that there is actually several different functions here. Read the lim, which is read the delimiter, read the CSV, which we've been working with. And then there's one that is called read CSV2. And if we read up here in the description, we see, okay, we have read CSV, read TSV are special cases of read delimiter, blah, 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 comma separated values, tab separated values respectively. And then we see read CSV2 uses semicolon for field separator, so to separate the columns, and comma for the decimal points. This format is common in some European countries. So when we have this kind of CSV file with semicolons, the fastest and easiest way is to use read CSV2 instead. So if we run this now, we see, now we got 5 columns. It says using comma as decimal and the dot as grouping mark. So grouping is when we have, if we somehow want to separate, so 1,000 is written, like if we want to write 10,000, we can write it this way. Don't care about it, just if you get curious of what grouping mark means, is what denotes when we separate thousands from each other. So again, we can look at the data and we see we're back to the same problem with the names because we didn't clean the names. So here again, clean names, we run it, we look at it, and now it works. We see again the problem with the NA. So inside the read CSV file, we need to add the NA argument, right? And here we said we want everything empty and everything that says N/A to be missing. We look at it, and now we're back to the same place. What is actually happening here is that if we look at the read CSV function, and we scroll down and look at we look at this one, read the lim. So we said here that read CSV, read TSV, special cases of more general read the lim. So the lim stands for delimiter. So just we want to read any data that somehow delimits, separates the different columns. And if we scroll down and look here, we will see, sorry, now I'm not finding it actually. This is what happens sometimes when you don't look through things in advance. Okay. We jump from this. I can show you more later on if we have the time. But basically what it does, it just changes how, like, it just changes the arguments for what is supposed to count as a separator, right? How should I know when the next column starts? That's all that it does. And again, we can have read TSV. So you might see a TSV file sometimes. Those ones, that stands for tab separated value. So if you have a file where instead of a comma, instead of a semicolon, you have a tab, that's another way of separating columns that is done in some, then you just use that one. So it's just different. The different functions here just tells you, just have different ways of saying this is where the new column starts. That's all there is to it. Those are the CSV or TSV style of data. the advantage with working with CSV files or TSV files is that they are not directly connected with any specific program, which means that it's much more portable. So if you are collaborating with someone that, for example, for some reason don't have access to Excel, then you might have a problem with working with Excel files, because all of a sudden you send it to someone and they cannot open it. Even more if you work with SPSS file, you have the problem of, okay, so what happens if I send it to someone that don't have SPSS? That's one problem. Another problem that is fairly common is that different apps, different programs have their own file format. And then all of a sudden, the company goes bankrupt. They stop developing the program. So then when you go back 5 years in the future, 10 years in the future, and try to look at the same data again, the program doesn't exist to open it anymore. And then you need, there are research settings, there are laboratories that have, I just read the other day, they have some €500,000 worth of microscopes, that these microscopes output files in a specific format, and then they stopped making the program for newer versions. So they have to have 2 computers running Windows 95 at the office just to be able to open these files, which isn't the nicest way. So comma separated values is a nice way of storing this kind of data, because you can open it in basically every program, every software system, like operating system on Macs, on Windows, on Linux, and everything. So recommendation if you're able to work with CSV files. Okay. But however, a lot of times you're not in control, right? A lot of times you just get data the way it is, and that's what you have to work with. So next step here is looking at what happens if we do have an Excel file. So again, we can go in and we can look at the Excel file, just open it up in Excel, see how it looks. And we see it's the same data as before. Same 5 columns, same 4 rows, same missing data here. So we're working with the same data, but now all of a sudden we got this to us in an Excel file. To work with Excel files, we need another package. So same as before, we create a new script. This time, this is the 3rd that we're importing. We call this import Excel. We need to load the packages, and in this case, again, first step, installing it if we never worked with it before. And the package that we're working with now is called Read Excel. So Excel for Excel. So if we install this package, again, install worked well. Library, so we load the Read Excel, and we know that we will want to clean up the column name, so we might as well directly load the janitor package. Read data. And now if, again, we meet the new package, best place to start tend to be just search for it. So we're going to do just that. Read Excel. I get it directly here, but we can Google it. Again, we see fairly early that the web page shows up. Okay, make it easy to get data out of Excel into R. We're on the correct place, right? Supports both the old format, so XLS, and the new format, XLSX, that are the different that are the different versions for Excel. We see that it is part of the tidyverse. So if we install the tidyverse before and loaded it, this is actually included. Perfect. We scroll down, how to install it. We see that it has a cheat sheet. Remember that we looked at them last week. So here we just kind of get a semi-visual overview of the different options. And we actually see when we go in, it's a general for data import. So here we have for the readr that we've been working with now. And then probably we scroll down, read Excel, and it actually even has one for a specific one for if we work with Google Sheets. We'll not look at it now, but it will work very similar. And here you can get the overview. So perfect. We have a cheat sheet if we want to go back just to get a little bit of help. We see here if we have problems with column names, if we have multiple header rows, like different type of little bit more advanced stuff. Here there's article or vignettes about them, so we can read more, get more help. Perfect. And under reference, we see all the functions available. And again, the nice part with this is that they tend to have similar structure in how they are named. So we see, okay, read Excel, right? Before we had read CSV, read CSV2. Now is read Excel. That makes sense, right? So we're back into R. We want to try to read this Excel file now. So raw Excel data is the object, is the what we want to name the data frame. And then we saw read Excel. Here it is. Perfect. Again, we start counting when we need to put the file in. You can just double check in the help page. Path, or like file or path. Path is where in the folder system it is. We have the file. So same as before, first argument inside the function is just where it lies. We start counting from here. So first we need to go into data raw. Once we're inside here, we see it's called the same. So just strength tests dot Excel SX, right? We read this and we see that it works. So we have 4 observations, 5 variables, looks correct. We check raw Excel data. We just look at it. Again, we see the problem here with the names, column names. So we do the same. We just add a clean names from the janitor package. Run it again. Run it here. Okay, perfect. Looks more or less the same. We see a couple of differences. One is that the test date is not a date format anymore. It's this is a date time format. So it thinks that we want to have not only the date but also the actual time. So the hours, the minute, the second. If we absolutely don't want it that way, we can again, if we go to the help we could see here column types. So here we could work with defining. So we want to say, no, the test date column isn't a date time column, is only a date column. We'll not do that now. But we do see a little bit here with the weight, right? Again, we see that it's character, so it's text, and we know that it shouldn't be text. We see the same thing here. When it was just empty, that counted as a missing data, but the second one didn't. So we see the same pattern here again. And if we open it up in Excel, again, here we have the empty cell. The empty cell counted as missing data, but this one didn't, right? So again, we can guess that it should be something similar. And here we say, yeah, NA. And here we see that the default argument for NA, the default option for the NA argument is just empty, right? So here, what we need to do, we need to go in and actually tell it, okay, so we want both when it's completely empty and when it's n/a. We run it, and now we see that this is a double. It's numerical. Both of these ones are missing. So that worked out just fine. One thing to keep in mind here is that you have the default value. So if we don't put anything in here, this function will say, okay, you didn't actually write anything. Then I just assume that you want it to be whatever it says here in the default. But as soon as you name this argument, as soon as you put the argument and start to change it, it will change to what you write. So it's not that it will add things. So again, here we see that NA equals empty. So then I think, okay, the empty cells is going to be missing. It's going to be NA, but I wanted to add also the n/a. So then I just say here, okay, n equals n/a, sorry, in capital, and say, perfect, because it already takes the empty, and now I just add the n/a. We run it, and now that we look at it, it works. Interesting. It's not supposed to work. And again, see, even when you work with these things, you get surprised sometimes. And this is why it's important to double check things. What I wanted to say in this case was, and what I think happens in the read CSV, is that if you put something new into the NA, it doesn't count the old ones. So you would have to be explicit about stating every way that you could have missing data in the files. In this case, it works anyway. I actually don't know exactly why. But again, if I really wanted to understand this, I would go in, I would read here in the descriptions, I would go down here, probably start checking NA. By default, read Excel treats blank cells as missing data. That's what we saw in the default, but it still doesn't explain. We see, but we actually don't get much of an explanation. So next step here for me, if I wanted to understand this, would probably be Google, right? So we could put like read Excel missing data argument, search, and then we see here, okay, GitHub is a place where people put a lot of their code, and you can also have discussions when things are not working and so forth. So we see that we're in the read Excel part here of GitHub. We can see someone has some problems. We could start to read through, see if we find answers. Okay, maybe not. Another good place is Stack Overflow. So Stack Overflow is a web page that is made for you asking coding questions and people giving you answers. So you could like kind of read through here, see, do we have, okay, and so forth. So that's how you would go about it if there's something that you don't understand or work that you want to get deeper into. And again, Stack Overflow and issues on GitHub are two good places to start looking for answers. Just Google function R if you need, and then something what is not working. If you get an error message, paste the error message and so forth, and search. And again, Stack Overflow, GitHub, good places to start. We're going to move on into SPSS files, but we're going to have a 14-minute break. So again, 10:15, we continue. So let me. Okay, perfect. Time to move on to the second part. So we've been looking at CSV files. We've been looking at different type of CSV files and how that might how we might work with that and work around different type of missing values and so forth. So we're going to move on again. Different type of the more normal data. One thing that is a difference between CSV files and Excel files is the fact that CSV files are always, if we open this up, one file, so one table, right? It's rectangular, so we have the columns separated, and then we have the rows separated with new rows. And if you want several different data sets, you save them in several different CSV files. In Excel, so again, if we open up this Excel file, we actually can have multiple worksheets, right? So if you ever worked in Excel, probably you've done it. So you have one worksheet with some information, and then you have another worksheet with some other information, right? Some other data. In this case, we have one for squats and we have another for bench press. So we see that it looks like the same type of data, but the last one changed, right? So one important part when we work with Excel data is to be able to choose which worksheets we import. And again, same as always, what do? We go here, sorry, let's actually just add to be explicit about that we want missing to be missing. We go into the help of Read Excel. We normally start looking here within what are the different options. And there is one that is called Sheet. Again, looks good. We go down. Which sheet to read? It can be the name of the sheet or the position. So, and again, if nothing is entered, if we don't have anything for this argument, it defaults to the first sheet. So again, if we just here, we haven't put anything, right? So when we import this and look at it, we can see that it's squats, kilograms. So if we go back to the Excel file, we see that this is actually the first worksheet. So that seems to be correct. It like if we don't tell it anything, it will do it from the first sheet, but we might want to actually import from the other sheets as well. So we can go here and say sheet equals, and then we said it could be the name of the sheet. So we could do here, let's say that we want the second one instead of the first. So second one is called bench press. So we could just enter bench press as a name. Again, in Excel, it started with capital, so we need to respect that. Sheet, bench press, and now if we import this, it worked. We didn't get any warnings or errors. We look at the data, and now we see, yeah, bench press kilos. So this looks correct, right? So just again, the sheet argument is really good for deciding which, like when you work with several sheets in the same Excel. And in this case, what we maybe want to do is what we get the data into different sheets, but we actually want to work with it as one data frame. So how this could look then is we could say first we want to get the squats data. So again, we could be specific here and actually say explicitly that it's the sheet we want is the squats sheet. And then we can say that this should be the raw squats data. We read this and we look at the data and we see perfect, we have the squats data. Now we maybe want to, so here we could just put a comment to remember what data. And now we want to do the same, but for the second sheet. And remember what we can do then is if we mark, we could copy paste, or we could do commando, option, alt, and down arrow, and we get a copy of it underneath. So this is another shortcut to working with to get this down, to copy it faster. And the second one was get bench press data. So then here we wanted the bench press sheet. So we did do bench press, and then we want to say, okay, this is supposed to be the raw bench press data. Okay, we read it, we can have a look at it. This time we could raw bench press data, and we see then we have bench press, the bench press variable here instead of the squats. Perfect. So if we're now thinking that we're in the data cleaning process, right? We imported the data, so we managed to get all the Excel data in. But now what we probably want to do before we analyze this to create our clean data is to actually merge this together. So going back to the last class, where we want to join the data. So then here we say we take the raw squats data. We remember how we need another package to work with. So here we'll need the dplyr package. We take the raw squats data. We want to do a left join. Remember, to join together, we take all the rows in the left data frame, in the first data frame, and we match it with the ones in the right data frame. And again, in this case, since they match up, since they are the same, it will actually not really matter which of the different, if it's a left join or a right join. But again, going back to last class, if you want more details on the different joins. Again, we have the raw squats data. We want to join that with the raw bench press data. If we now run this, we remember from last year that it says joining with, and then here it says which argument it guesses. So which columns should we match the two data frames on? So when athlete name is the same in both, when sex is the same in both, when test date is the same in both, and when weight in kilo is the same in both. This is guessed because it has the same names in both the data frames. But again, it's good to be explicit about this. So it's good if we are happy with this, we just copy it, we paste it in here, and now you will see that if we run this again, you will not get that text because it doesn't have to guess anymore. We explicitly say what to match on. So now we got a nice clean data frame. So we could save this as clean data. And when we look, and then probably what we want to do is to write the data. So we would want to use the write CSV file because it's better to save it as CSV, right? So we will load the readr library, and then we would say we take the clean data, we write a CSV, and again, probably we'll want a data folder, so we're well organized. We actually, so we would say we start again counting from here. We want to say we want to go inside the data folder, and we want to save this as clean data.csv. We try and it doesn't work, and it says cannot open file for writing data, clean data. When this error shows up, which it will do when you work, this basically tells you that the folder doesn't exist. So R doesn't have cannot just create folders by itself. However, you actually need to do this. So we create the data folder, shows up here, and now if we write it, now it worked. If we go into the data, we see that we have the clean data here. And if we actually view this file, we see that we have athlete name, sex, test date, weight, squats, and bench press. So now we have all the data that we were interested in. So again, even if you start to import from one format, the raw data, you clean the data, you tidy the data, and generally then when you save the clean data, you want to try to save it in a CSV format anyway. And that comes back to the fact that it's easier to make sure that you can open it on another computer with someone that don't have Excel in the future. So it comes back to the reproducibility. So this is the example of how to do this in Excel. We restart, as always. When we open a new script, we want to start from 0, so we don't have any old objects here. So we worked with the CSV with a semicolon and the Excel. Next step is, okay, so let's say that maybe you're more into a research setting. A lot of researchers use SPSS. So if any one of you don't know, SPSS is a statistical program. It's made for doing kind of statistical analysis with pointing and clicking. It's very well established. It's used a lot. So you will, if you're in a research setting, you will undoubtedly experience getting SPSS files. And most of SPSS files have the SAV file handling. So when you see a file that says .sav, you know that this is probably an SPSS file. I can't actually show you how the file looks in SPSS because I don't have SPSS installed on my computer. That comes back to the fact that it's quite expensive. So it's not all universities that pay for the license, which is another argument for using R or any Python or any open software that's free to use. But anyway, same as before, we create a new script in the data raw. Now we're down to the 4th. So we're in the 4th, which is import SPSS. The package that we need to import data files from SPSS or other statistical programs is called Haven. So again, we could just R package Haven, and in the R for Data Science book, it goes through these things, so you can go in there and have a more detailed look at all of them, and that's also where you can see which packages is a good way of getting to know which package should I use. But again, we see here import and export SPSS, Stata, and SAS files. So These are 3 different statistical programs. This is what we want to work with. Again, it's part of the tidyverse. So if we've installed the tidyverse, we don't need to install it. We could load the tidyverse instead of loading the individual packages. I prefer to load each individual package to have a little bit more control. And if we just take a quick look here, we see read underscore the name of the file ending and write underscore the name of the file ending. So the naming of these functions work the same way as before. So we go back to our script. We load packages, and in this case, it will be Haven. We want to read our data. And here we, got stuck there. Same as before, raw SPSS data, for example, and read SAV in this case, right? Check here, SAV is the file ending, looks good, perfect. File is the first argument, so where it goes, we know that is inside the data raw, and inside the data raw, the name is strength tests.sav. So strength tests.sav. We try to run this, and we see we don't get any error warning messages here. That's typically a good sign. We can have a look at the data. Raw SPSS data. We run it, and it looks fairly okay, right? So we see here some things you will typically see is that in SPSS files, the columns can't have spaces either. So you'll probably get a bunch of names that are just where you separate the different words by starting the next word with a capital letter. This is sometimes called camel case. So when we have underscores instead of spaces, we call it snake case because it's like a snake. And when we instead use capital letters to, like, instead of putting a space here, we just start the next word with a capital letter. That's sometimes called camel case because it's like a camel with bumps. Don't know why someone decided to name it, call it that way. So just if you see snake case, that's when you have underscores. If you see camel case, that's where you have capital letters. So we might want to work with this, fix this into the format that we're used to working with in R. We also see that typically inside SPSS, the files have already handled the missing data. So it will come in nicely and clean with the missing data. We probably don't have to do any special things. And if you do, then you go in and read into the help and read into the vignettes, the articles on the website to get more details on that. One thing that do tend to happen a lot of times, though, is this column. You see that here, instead of just having male and female, we actually have a number. So we have 1 and 2, and then it kind of grayed out, says female and male. And this is because inside SPSS, when you work with factors, so when you work with kind of different groups, or when there's few options, so you might want to say, we want to compare male and female. So these are 2 different groups. When we work with that in R, a lot of times we can just use text. Sometimes we can want to convert the variable into what is called a factor. So a factor is when we have these different groupings and it says, okay, all females belong to one group, all males belong to one group. We haven't looked into it because before you start kind of with statistical modeling, a lot of times you don't really need that. You can just have it in text format. In R for data science, you can read more about factors. So I would recommend to do that if you want to do work in R. But here we need it anyway. So we have a column that is a double plus LBL, which in this case is label. You don't need to remember this, but just so you know. And if we look at the columns here, we see that they have extra information, what is called attributes. So if we go here to sex, we see that it has what is called labels. So when we see that it has labels, we know that, this is something where the actual data is numbers, but each number means something. So group 1 is female. Group 2 is male. So this is how SPSS works with it. We don't really want it in this way. We prefer to just have it saying female or male. And what we do then is, again, first steps first, we want to get nice clean names. So we want to have our janitor, and then we want to clean our names. Yeah, so now we are working with snake case names. And one thing here is, if we look at the original data, we said we had the camel case where you just start with a capital letter. Here you see that it's the one that made the file made it wrong because it's not capital letter. And then you go down and see, so when it starts with a capital letter, even if there is no space, this function will guess that you actually wanted a space. So when you have these camel case versions, it will also include an underscore to denote a space. If the one that made the file used the capitals correct, because you can see here we have weight underscore kilograms, but we don't have squats underscore kilograms. We just have squats kilograms. And that's because if we go up and look at the original, we see here weight, and then kilograms start with a capital K. So then now the clean name function knows that, here we want a space, which is an underscore. Here, the person that made this file, which was me, so I'm the one at fault here, didn't actually give this, put a capital K, which then obviously means that the function cannot identify this. We could now go in, just if we want to fix this, we could go in with a function from dplyr, which is rename. And in the rename, we could just say that we want to have a column that is called squats underscore kilogram. And we want, like, this is the new name that we want from the old name that is squat kg. If we run, did I spell, look, misspelled, I missed an S. If we run this now we fix that name as well. So again, going back to how we can combine these functions to just make sure we have the data in the format we want. Now we're here. So we read in the data, we have the correct kind of variable names. But now, again, we need to clean the data. And in this case, it's mostly this column we want to work with. And the function we want to use here is a function C that comes in the Haven. So we could go here and check references. And here it says here, labeled vectors. So again, remember when we went in, we saw here, we say this one labels, it has labels, right? So it's labeled. If we want to work with them, labeled vectors, which are similar to factors, but a little bit more general, blah, 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 blah. And here we see convert labeled vectors to factors. So factors is what we want to work with inside R. They come in as labeled vectors. So we want to use this function. And again, if we go back, remember from the class where we were transforming variables, remember if we want to change anything in a variable, create a new variable or change anything in a variable, is the mutate from the dplyr package. So in this case, we want to mutate. We could create a new variable. We could say sex2 equals, and then as label, as factor, and then we want the sex column, sex variable, right? So if we run this now, you will see that, now we have it in the format that we are used to, right? That it says female or male. But actually, in this case, this column we don't need anymore, right? So this column is the same as this, just fixed to a nice format for us to work with. We don't really care about this. So so again, instead of creating a new column, if we just call the new column the same as the old column, it will override it. So if we run it now instead with the same name as the old column, we get a new, the old column is just changed to be factor now. So we work with the kind of male, female text in a way that we want to work with in R. Now we're ready. Again, now we could go into save clean data. We want to save this as clean data, and then write CSV, blah, 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 the same as we just looked at with Excel file. So that's that. Typically don't tend to be that much problem, but again, Haven is the package you want to work with. And again, you scroll down and you have here articles, date and time, conversion semantics. Under conversion, you find more about the kind of labeled variables and everything. So how to work with missing values. You can do a lot of more advanced stuff with it. So if you need that in any moment, when you need it, go in a read. Don't lose time on it before you need to use it. So this is importing data from a couple of different ones. One way is, again, let's say now that we just want to add some extra information. Let's say that we have some information about the two athletes, right? We also know their height, which might be interesting to add for some reason. Or we just have a couple of data rows that we are not actually it's not worth it to create a full file, put it in the data raw folder, import it, work with. We just need to kind of quickly and dirty add some more info. What we can do then is, we close here, we restart. we create a new script here, and this is the 5th version, and that is create data frame, right? So we could just directly create a data frame inside R. And this is done with, again, you can do it directly in R without loading any packages. To work well with the other things we're doing, the other packages we're using, we're actually going to use a package called Tibble. So again, Tibble is part of the tidyverse. It goes well with a dplyr, with all of this, with all the other packages we're working with reading data. So when we loaded this package, the way of creating a data frame is to call Tibble. If we check, so here the name of the function has the same name as the package, so that can be. Has a lot of description. It compares it a little bit to just a normal data frame, like why is this better to work with, so forth. You can read more about it if you want. And then we check the arguments. And the first argument is the ellipsis, so the 3 dots. Set of name value pairs. This is, again, maybe a little bit hard to understand at first. So we just scroll down, and a lot of times the examples is a good place to start. So basically what we do is we will tell it, create a variable with these values, right? So we could create a data frame where we say, we want the variable, we want the column A that is equal to 1. If we run this now, we see, we have a table that is 1 times 1, so it's 1 column and 1 row. The name of the column, the name of the variable is A. That's what we put first. And the value in the first row is 1. So this is the basics of how this works. And if we now would save this into new data, we see new data, 1 observation, 1 variable. The variable is A. If we open it, it looks just as the data frames we've imported from external files, just that we created it this way. Now, oftentimes you don't really just want 1 value, because then you don't actually need a data frame. So let's say that we have several values. So we want to create multiple rows. What we do then is we need to say that the variable A is supposed to be a vector of different values. So we could do here 1, 2, 3, 4, 5. Yeah, we run this, saved into the new data. We see 5 observations of 1 variable. We just check it out, new data, and we see we have the variable A with, now we have 5 rows that just go 1 to 5, right? This could be something else. This could be, we could change the order. We could have 1, 3, 13, 4, and a missing. Now this is only, we run it, we check it, and now again, the values just show up in this order is the rows, is the order of the rows that you want to create, right? So we say 1, then it's 3, 13, and NA for missing. So this is how we create 1 variable. Now, probably we want to create several variables, right? So again, a comma to separate that we want a new argument. Now we want the new column. And again, here then 1, 2, 3, we have 4 rows, so we need 4 four values here. So let's say that now we want this to work with text. This might be the name of the athletes. So we have John, Eric, Amanda. Sorry for the Anglo-Saxon names. The English names is just the first that pops into my head. Too much American TV shows. And we already used Eric. We use Noah, right? So we have four values for the A variable and four values for the B variable. We run this. Now we see four observations, two variables. We take a look at it and we see, yeah, okay, so we have a first column that is numeric, is numbers with the four. And we have a second column that is characters, that is the four names we put in. And this could, of course, be, so it might be that we have two observations for Amanda, right? So now if we look at it, obviously, we can have the same value in several rows. What we can't have is same name of the variables, of the columns. So if we try now to say, we just do something easy, right? So we have a third column that is also called B, and we have four different values here as well. We run it, and now we get an error. Column name B must not be duplicated. We have it 2 times, right? That's not what we want. So, okay, then we would need to call this something else. Now it worked. We call it another name, and we look at it. Now it works. Perfect. One thing to keep in mind when we do this is that the variables all have to have the same number of values, right? So if we now, for example, would forget to put 4, we just put 3 because if we thought, and then Amanda should get B twice, and we try to run this, you will get an error. Table columns must have compatible sizes. And then we see size 4. Yeah, most of them, they want 4, 1, 2, 3, 4 rows. But column B, this column, only has the size of 3. So it only has 3 values. So it doesn't know how to create this, like, because the 4th row, which value is it supposed to have for B? We didn't tell it, so then it prefers to just throw us an error than try to give us some weird guess that probably is not right anyway. However, there is one more option, and that is that a variable, all the variables need to be the same length, the same size, so the same amount of values, or one single value. So it could be that for all the rows that we want to create, we want the C to be 4. Right? Now what it will do is it will recycle the 4 for every row. So if we try to run this now and we look at the data, we see, again, for A, we have 4 different values, 1, 2, 3, 4. For B, we have 1, 2, 3, 4. Not different values because Amanda is the same, but we have 4, 1, 2, 3, 4. And again, the C, even if we didn't put 4 values in here, if we only put 1, that will work. Then it will just put that value into every row. So it either needs to be all the same length, all the variables, or it needs to be only one character. One last thing to go through with creating data frames directly in R is that this one's, you see the similarity between this and how the mutate looks. Remember when we looked at the mutate, it was we take a data frame, then we put the mutate function, and inside the mutate function, we put what is the name of the new column and how should we, which value should we put in there. This one's actually work the same way. So we could do calculations directly in here. So we could say that we want the C column to be equal to, we want the C column to be double of the A column. So we could just say that C column, the C variable should be equal to 2 times A. Because A, then we refer to back to the column that we are just creating. So we can do this inside the same. So we don't need to create first this data frame, then use a mutate function. We can just run this directly. And when we look at it, we say, okay, 1 times 2 equals 2. 3 times 6, 3 times 2 is 6. 13 times 2 is 26. And missing data times 2 is missing data. So this is how you can work with these ones. Sorry, this is how you can create your own data directly in R if you for some reason need to do that. And again, now you could save this into a clean data and everything, but just shortly showing. Or it might be that you have other imported data, but you want to just join it together with some data that you quickly write in here. Last thing I'm going to show you before the break is, so we've been looking at doing this, again, restart R. We've been looking at how do you import it with the different functions, how do you like different functions for different files, etc., etc. There is one sometimes a little bit easier way to do this, and that is if we click on these files. So we're in the file pane, right, where we see, again, here is our project. We go into the data raw. And then it's the thing of like, okay, I have my raw data, but I don't really remember which was the package, which was the function. I might have problems with my columns. They are not in the correct format. The NAs doesn't work. You can read and use the functions, which a lot of times you will once you start to remember more or less which ones are which. But we can actually, if we click on a data file, there is an option to choose import dataset. And then we get up a nice little window here with where we see where is the the path, right? Where is the data? It gives you a preview. This is how the data will look when we import it. And here you can check character. Then remember the problem we saw here with the NA not being correct. So then here we can look at more options. What do we want to call the data when we import it? NAs. Okay, here we have a couple of different options. But we see that in this case, they actually don't really help us that much, but could be. We could check here. We look, okay, this shouldn't be numerical, right? This column should be a date. Input date. Okay, which is the, okay, we're getting into more complex things here, but we skip that. But you can work like this one. We know we didn't want it as a character. We wanted to have it directly as a factor. And then I will need to say that it can be female or male. So like work with these things. This one we want it to be double, blah, 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 these kind of things. And then what happens is we can import directly. If we just click here, we will import it. This we want to look out for, because if I just click here, it just runs the code that needs to import it, and I imported the data, but I have no way of redoing this, right? I just import it. If you just quickly want to look at it, this might work, but what you actually want to do in this case is we have our R script that, like, we're importing data, clean data script, whatever. We click on one of these ones, import data set. We do the things we want to do. We wanted this one to be numerical. We don't want to call it strength test. We want to call it raw test data, blah, blah, blah. And then you can see here that you have the code, right? So you can just copy it, either click on the clipboard, or actually just mark it, copy. If we now cancel, and in our script we just paste it, we get, this is the library that I need to load, and this is the code for how to read that CSV file with, remember that we said we want to be specific about which type of variable we want the weight column to be. We import it, now we can view it, and now we have the code in a way so we can reuse it later on. But it's a good way when we're not really sure, and it might be like the SPSS file. So we're not interested in this, we restart, but now we want to import it from the SPSS, and we're like, how the hell was that? Which was the package? I don't remember. I don't know where to start. Okay, click on it, import data set. You get a nice preview. Again, you get, here is the code. We can just copy it, cancel here, paste the code, and now when we run it, perfect, we import it. So a little bit of a shortcut that can be good to know. We will pause here. After we get back at 1:15, we will look a little bit at JSON files quickly, because you might meet them, and then we will start to go through the examination. So 13-minute break. Start the recording again, and we'll move into the last part of the class and of the subject, actually. So as I said, we'll look a little bit about one more type of data, little bit different type of data, and then we'll go through the examination. So JSON is another data type. So is what might be called a hierarchical data type, where you have things more listed inside each other rather than just in in a rectangular format. So both the CSV, the Excel, even the SPSS files have all been kind of more or less already in the tidy data format with variables and observations, so columns and rows. Sometimes we need to change them up, move them around, pivot them longer or wider, and these things, but they're still kind of in that format of columns and rows. JSON data, we have one file here, JSON. So if we take a look at the data, if I just click on it to open it, we see that this data looks different. It's in a different form. And it's probably even supposed to look like this. This is more aligned with when you work with objects. So might be a little bit more usual to work that way in Python, but especially this comes from working with JavaScript. So we're talking web development. And this format is also, as I said, really common when you work with APIs. So sometimes you might have, let's say, for example, that you have access to Polar or Garmin, so heart rate monitors for a team, and they nowadays offer ways of getting the data out, not in their own web format, but you can get out the data to work with. So then you kind of have to have a login to get access to it and so forth. But it's basically like a web address that you go to, and then you get out the information that you want. And a lot of times it will be in JSON format. So it would look something like this. Again, if we take a look at this, we can see that more or less we have the same data, right? So we have one object, like each object is the thing inside these parentheses, right? These curly brackets. So we have 1, we have 2, we have 3, and we have 4. So the same as the number of rows we had before. And we start to look here, and we have athlete name is Amanda Smith. Sex is female, test date, blah, 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 weight and squats. So we see this is really the same data that we worked with in the other formats. The only difference is that they're grouped by kind of by row instead. So we have like, here is all the information about this observation, here is all the information about this observation, and so forth. And here you can see, for example, that here we have the weight. So the weight in kilograms for the first observation is 65.3. But the second one, remember, that was the one that was empty last time. It doesn't exist. So we can just say that the second observation don't have any weight information to it. So same data, different format to work with it. And to work with this, we need to have another package. So we create a new script. We're in the 6th now. So 6th import JSON. And this time the package we need is called JSON Lite. So we will install the package JSON Lite. Yeah, install, nice, fine. We can even do, we can search. So we search again, JSON Lite, it's always good. We see here, CRAN page, go in, we look, okay, JSON parser generated, blah, blah, blah. Simple, flexible tool for working with JSON. A lot of times we go to the URL, so we go to the web page. Here we see this one looks different. Okay, we might be able to get some, but here it looks like, okay, this might be more of the development page. We don't find easy information. Okay, sorry, if we keep that one open, we go back on the CRAN page. Here we see the vignettes, right? Getting started with JSON and JSON Lite. Here we see fetching JSON data from REST APIs. So this was the access points I was talking about. So here you can read up more about this. Yeah, everything. In the R for Data Science book, You can read up more on this under chapter 23, that is hierarchical data, and you will see why this is hierarchical in a moment. But that's where you can get more information, because this is a little bit more complex to get our heads around. But again, we need to load the package. So library JSON Lite. Now we want to read our data. So then it will be, we want to say raw JSON data comes from read JSON on the JSON Lite package. So again, we follow the same naming convention, the same way. Path, this is the path again to where it is. To where the actual file is. So again, starting from the base folder of the project, we go into the data raw, so into data raw, and inside the data raw, it's strength tests.json. So strength tests.json, we import it, no errors or warnings. And we see that we have the data here, but we see that it looks a little bit different. We don't have information about the observations or the variables or anything. We see it says list of 4. So if we now try to check this data out, we see that it looks quite different. So we see here, starting from the top, we have 1, and then inside the first, we have something named athlete name, and then it's Amanda Smith. Then we have something that is called, some information that is called sex, and there is female. So we kind of see the data. You see that it looks a little bit more like the format, how it looked inside the file. So going row by row with all the information about it. This gets even clearer if we click on this. So we open it up. You see we have the raw JSON data, which is a list. So a list is just a type of vector. So when we have multiple values together, it's 4 objects long. So 1, 2, 3, 4 objects. Inside the first object, we see that we have something that is athlete name, that is Amanda Smith. Sex, female, test date, blah, blah, blah. We can do the same for the next, and the third, and the fourth. So again, if we now, we compare this, so we see first, second, third, fourth with the information inside. So we see that now that we just imported it directly, it kind of keeps that hierarchical layout. So we don't have it in a nice data frame that we like to work with. One little tip just to show you our studio tip. So when we work with this, when we maybe want to compare 2 different tabs here and these things, we can pop them out by clicking on this one, show a new window. If I click here, it jumps out into a new window, which makes it possible, for example, to have this one here, and then we have the other one here. And now it might be even clearer that we have like first one inside the first curly brackets, athlete name, sex, test date, weight, squats. Here we see the next one only has name, sex, test date, squats. We're missing the weight because we're missing it here. So again, we're comparing, we're seeing that it follows the same structure, but again, the pop out, like showing new window, is quite a good function to know, to just get it out in a different window. So what we will do now is we want to try to get this into the data frame format. And for that, we will use the tidyr package. And And the first step is actually to get this into a data frame to at least have the correct rows. So we have the raw JSON data. And again, what we will do is, we will have the table package as well. So remember that we looked at creating data frames directly in R with Tibble. Is exactly what we'll do now. We'll do Tibble. We will create one variable that we can call raw JSON. And we want this variable to be equal to the data that we read in, the JSON data that we read in. So we have, we create a new data frame, a new table, where we create one variable called named raw JSON, where we want it to be equal to this list of 4 values. So when we take this out, when we run this now, we see that what it actually creates is, again, a table, a data frame with 4 observations and 1 variable. And then we see that now we work with a special format. So now each value is a list. And we can say list, a named list with 5 values. So if we now call this raw data frame, for example, save it. If we take a look at this here, we see again, we have the variable name, we have our 4 observations, but the value in each is the list with athlete name equals Amanda Smith, the sex equals female. So what we saw here in the raw JSON, we can see that it created one new row for each of the observations we have, for each of the elements in this list. And the row, so the raw JSON variable, the value for that for the first row is equal to all this information together. So just say, put all this information, we have named attributes, so we have the name of the thing we're interested in and the value together. This is how that looks. The thing is, now we want to get these different ones. So we don't want one one variable that is raw JSON. We wanted one variable that is athlete name. We want one variable that is sex, and so on with all the different ones. To do this, we will use a tidyr function that is called unNestWider. So remember that before, when we worked with data frames, we had pivot longer, pivot wider. So we're saying, should this go into several columns or should this go into several rows? unNestWider and unNestLonger works the same way, just that it says take the different values inside an observation and put them into different columns or put them into different rows. And most of the time we are working with the wider. So we take the raw data frame that we have, we call here unNestWider. We see first one data. This is the data that we want to put in. We go to the help page, so the data, the next one is call. So which is the columns that we want to put into several columns, right? And in this case, if we look at the raw data frame, so we look at it, it only has one column, right? Is the raw JSON. So we just say, is the raw JSON column that we want to unnest, so unlist, don't have it as a list, and we want to do it in a wide way. So each different value we have in there, we want to put in a new column. If we run this now, we go down, we see here, yeah, now we took the first one, athlete name. Let's put them all into one column. Sex into one column, blah, 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 blah. So now we're back to our rectangle way, the data frame of having variables and having observations in a nice rectangle that we can work with. Again, we see the same with the names. So here we would just library janitor, load that. And here, after we unnested it, now we also want to clean names. We run it, we see now it looks just as all the other ones. We can save this one into clean data. Now we can write clean data. And again, here we take our clean data. We want to write a CSV file. Again, then we need to load the readr, because that's where this is the package we use to working with CSV files. And CSV files are to create our clean data. It's nicer to work with, it's easier to work with. Again, we said that the clean data should go into the data folder. So we have data, and inside the data folder, we might want to call it clean data again, .csv. This is the old one. We said this wrong. We don't have it. So now when we write this file, we created the data. And if we look at it, we see that it's in the format we want. So again, this is how you can work with JSON files. So when you have these kind of, when the data looks like this. Again, you can read much more about it. You can get into lists, what it is and everything in the R for Data Science in the second edition inside chapter 23. Here you see it talks first about lists and unnesting, and then it goes into JSON. So it talks about the JSON files as well. One thing that we don't have time to look at, but that might be interesting for you if you are doing more data work, is web scraping. So the next chapter here, chapter 24, is all about, so how can we go into a web page and say, I want to get this data down and not have to copy it. So just go page by page and copy. How do we want to do to actually go to a web page, find the data we want and automatically extract it, and maybe do that from multiple different pages. So again, we don't have time to go into it, but there is a chapter on it if you're interested in it. So if you have data on web pages that you want, look into the web scraping. That was that for the data import part. So again, we have we looked at comma separated values with a read CSV. We looked at comma separated values that are actually semicolon separated values. So what is more typical in some European countries, the same readr package, but we use the CSV2 just to say that we work with a different delimiter. We worked with Excel files, importing them with a read Excel package and the read Excel function. We worked with SPSS data, so .sav data with a Haven package and the read sav function. Again, this works for Stata files, this works for SAS files, which are other statistical programs, and then it's just same package, Haven package, but you will change this instead of read sav, it will be read SAS or read whatever name we use. We looked at creating the data frames directly in R with a Tibble package and the Tibble function that was similar to how Mutate works. And now we looked finally at the JSON files that are different in how they are structured. One thing I can recommend looking into is if you're going to use Excel, how do you use Excel in the best way possible to not run into problems? And last week, I asked Florian to upload 3 papers in 3 scientific articles in the online, like Würzburg online, or what it's called, the online place. This one is the one I definitely recommend that you actually take a look through. Data organization in spreadsheets. And we can actually, I could actually pull it up quickly. So there was 3 articles, and this one, the Broman and Wu, is the one on data organization in spreadsheets. Talks about several things like be consistent, make sure that you always call male male and female female, don't use different ways of doing it. It talks about how to choose good names. So we've touched on this, how you do things. Here it goes more into details about that. How you work with dates in a good format. You if you go back and look, you see that I always work with the ISO format, so the standard doing year dash month dash date, which is the easiest way for programs to read dates. You can see more about that. The thing of not leaving cells empty, like duplicate values if you need, or use NA, like use some way to explicitly say that is a missing data. A little bit on not mixing and matching different variables in the same cell. Split it up to several columns into several variables if you need. Rectangle, we talked about tidy data and how that data is rectangular, so not we don't want it looking this way with like no variable names, missing data here, this is supposed to be the same, and so forth. So try to get it into that tidy rectangular format. And goes through several. Create a data dictionary. We haven't looked into that, but actually have information that explains what the different variables are and how they work. Don't start to make calculations directly in the data. Use that in a different way. Again, you saw when we imported data sets that we get the data, but we don't have like font color highlighting that don't go in. So it's bad to use like red cells to denote something bad. Is better than to create a different variable that is called bad, good, bad, or whatever we want. And all of these things. So this one, and it's fairly easy to read, is not one of the heaviest scientific articles, so it should be fairly readable. I can really recommend, as soon as you want to work with any data in Excel, read through this one. It's a strong recommendation. The other 2 is one little bit older, about tidy data. So if you're interested, this is in no way something you need to read, but if you are more interested in like what are the theoretical background to tidy data, if any of you work with databases in any way, how does tidy data relate with relational algebra and these things. So it talks about it, it discusses it. Again, nothing you need to look at. If you're super interested, it's an interesting read. It's fairly easy to read as well. So that's a tip. And then the last article is applied towards research towards science, but have several interesting parts, even if you work more in practice in a club, in a gym, in these things. And it's the thing of what is good enough practice in scientific computing. So what to try to make things reproducible, and we're able to go back and someone else is able to go in and look at these things. What is the minimum we should do? Like, I guess you've heard sometimes of best practice. So what is the best practice? This one doesn't say what is the best practice, how should you code? This just says, how can you make sure that your code is good enough? And it goes through several parts. It goes through how do we manage the data, save the raw data. We mentioned this. How do we create the clean data? How do we store it? How do we work with software to make sure that some other one or ourselves in a year when things are updated can go back and know kind of which program created the things? How can we collaborate? How can we work with to-do files and so forward? How do we organize projects? We looked into this, right? So where do we put the different things? How can a project layout look? This is not done in R, this is in Python. That's why the scripts are PY. So I've used a little bit different ways of naming it, but it talks about the importance of having a structure for how you name and how you order things and so forth. So this one might be a good read. Again, not necessary for passing or anything, but it's I could recommend reading through. That is that. So last part, and probably what you're most anxious to see, in the Dropbox folder that I sent you the link in the beginning of class, I've now added this PDF that is with information about the examination, like the project, the examining project for this course. Florian will upload it today. I will make sure to give Florian all the information today so he can upload it as well to Würzburg Online or there. I could even, if any of you are really interested to get this right away, we could actually do something. I could just drop this into okay, no, I can't. So again, the Dropbox link I can send you directly. In the Dropbox link, you will find the document and find all the information. The examination will consist of you doing a data science project from start to finish. Again, from you will do the project starting with importing the data, importing external data, tidy it up, transform it, find some way to visualize it. We haven't looked at the modeling, don't worry about that. Visualize can mean summarize in table or in figure, and then save your tables and figures to be able to communicate it with someone else. So that's basically what you need to do, the analysis project. And apart from actually doing practically the project, you will need to write up a Word document or a text document where you explain different parts of why and how you did the project. So what you at the end of the day will have to hand in to me is, one, the project folder with all the code, data, scripts inside it, and two, a document in Word, PDF, or similar, where you explain more detail, more background about the data, which things you had to go through, and so forth. You need to email me to this email, anton.kalén, KALEN, at sok.se. The deadline is the 1st of December at 6. Again, we don't want to do any late night work. You need to sleep to stay fresh. So nothing, no 12 p.m. deadlines, especially not on Fridays. You should enjoy your Friday nights. So you need to send it before 6 o'clock. Friday, the 1st of December. So that's 3 weeks from now. Originally, I said 2, but I've extended it to 3 for if, I mean, you have other things to do as well. So it might be a little bit tight on time in 2 weeks. My tip, though, is get started on it as soon as possible. Just to go through a little bit, the analysis project, again, you need to create an R project. You need to go through all the steps, having some data, importing the data, tidying the data, transforming it, visualizing, and saving the visualization. You can use some of the data that we used in class the previous weeks. So the two major data sets. That's perfectly fine. The only thing then I ask is that you don't do exactly what we went through in class, right? So don't just copy paste what we did and send it in, because then I cannot see that you've actually understood anything. Then I'm just know that you paid attention and know how to use Control C and Control V to copy paste. So it's absolutely okay to use that data if you want. Again, you can do similar analysis as we did. That's fine, but don't do exactly the same, right? Show that you've done it by yourself. Keep everything in the project folder with the data and the code. You will send it to me, and I need to be able to rerun the project. So when we talk about reproducibility, is the thing of, I can do something right now in my computer, but someone else, my collaborator, my examiner in this case, like my teacher, need to be able to rerun the same thing. So that's why we want to work with an R Studio project. You need to send me the full folder with everything inside it so I can try and rerun and see that it works. The easiest way for you to do this is probably, so if you go in to one project you have, so let's say that you did best MBA team season, this is my project. Inside that was bad because we didn't use here the cycling training that we did last week. I have it organized. I have my R project file to show that it's an R project. I have my different parts of the project. So we have the raw data. We have the script to clean the data. We have the script to analyze here the data, create what we want, and we show that we can write it into the final format. Easiest way to send this to me is just if you take the top folder, right click on it and choose compress. And on Windows, this should be similar. I think it's called compress or zip. But again, you should be able to just right click on it and zip it. And then you have it in a zip file and you can just send me the zip file. This is absolutely the easiest way to send this. Again, remember to use sections. So Command or Control Shift R to create these headlines. Remember that we've been using, if I open one of here, remember that we use these ones to create kind of an outline so we can see the different steps. Use comments to explain what the different parts of the script do. Again, don't explain how. So he's not saying use the read CSV file to import the blah 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 .csv file. No, that you're supposed to see in the code itself. What you want to say is, for example, import the raw data, calculate the average of blah blah blah. So use comments in the script to explain what it is that you want to do, not how you do it, what it is. That is that part. Again, to pass, like the minimum to pass is that it contains the different steps, that you show that you can import the data, that you show that you can save the clean data, no matter if it needs some tidying or not. Like maybe the data is completely in the correct format from the beginning, then you don't need to tidy the data, just show that you can save it into clean data. Load it in. If you don't need to transform any variables, then don't, but you need to create some kind of summary table or create some plots, and you need to be able to save them. That's the bare minimum to pass. Send me the folder with that information, with those different sections, and send me a text document, PDF, Word format, or could even be like a Google. If it's a Google Sheet, Google Docs, please just save it into a PDF and send it to me, where you need to talk about kind of what it is you've analyzed, why did you choose that data, what is the background of the data, like where it comes from, how was it collected, why did you organize your project in the way you did, which steps did you have to go through, why did you choose to summarize the things in the way you did, talk about what did you do to make it reproducible, and just summarize it a bit. Doesn't need to be exactly these headlines in the explanatory document, in the Word document, but it's a tip. If you don't have any better ideas, use these headings. To pass, you need to send me working code, like working project, and the document with these things, where you have text, like saying something. That's enough to pass. Right? If you want better grades, you have in the end here grading, again, to be approved, send the project that contains all the steps, and send the document with the text explaining. That's enough to be approved. To get better grades, I will look at, is your project well organized? Do you have good names for things? Do you have subfolders in a good way? Is it easy when I open the project? Can I understand where what things are and what the different scripts do? So is it organized? Is it named well? Did you use the comments to explain the code? So if I go into a script and I look at the script and see the comments, can I understand what each of the different parts is doing? Do you use another data than the data in class? That's a positive. So that will reflect on the grade. So again, fine to use the data. If you do really good stuff apart from that, you will get a good grade anyway. But one way of showing that you're even more capable of doing a data science project and handling information is showing that you can do this with some new data, some data that we haven't looked at together. Again, It might be that you don't actually need to do any data cleaning or data tidying. That's fine. You pass anyway. But if you show that you can join multiple data sets, that you can pivot data from wider to longer, that you can select just the variables we're interested in, that's positive for the grade. So that's good. Same thing when you summarize, like when you do the analysis, create the summary. If you show that you could combine filtering, mutating to create new variables, summarizing by different groups and these things in the transformation phase, that's also a good way of getting better grade. If you don't need to do any of this and you don't want, you just want to pass this, don't feel that you need to. But again, doing these things and especially combining several of these steps will help you get a better grade. And finally, a big part of getting a better grade is how good do you actually explain and discuss the things in the document. So can you actually explain where does the data come from? Can you explain something on how it's collected? Talk about file format. So the more of these questions that you're able to answer in a good way in the document, again, the better it will reflect on the grade. So to summarize, you can find this document directly on Dropbox now if you follow live. Otherwise, it will be uploaded. Florian will upload it so you can see it. You have 3 weeks to complete it. It needs to be complete to send in before 6 on Friday, the 1st of December. My strong recommendation is, even if you didn't manage to finish, send in what you have so you can get feedback on it and then hand in a second time with the feedback based on the feedback. So like, if you're interested in getting a grade, send in what you have before 6 o'clock in the afternoon, Friday, the 1st of December, no matter where you are along. If you start to send in things later on, that will look bad for the grade. You can pass even if you send it afterwards. So it's not a hard deadline. But again, same as if you do a data science project for someone, they will say, I need to know how good our players did on these tests before next game to know who should play. Again, if you come with that information after the game, that doesn't look good for you. So hand in what you have before 6 Friday, the 1st December. And that's about it. Hand in the 2 parts. Do what you did, what you had time to do. The better you do it, the more of the steps you go through, the better it looks. But again, the bare minimum to pass is hand in these 2 parts and make sure that the code runs. And you can go from importing data to exporting summary table or plots. Is there any questions right now on the examination from anyone? I take that as a no. Either is a no, or this was so boring that everyone fell asleep. I'm hoping for the first one, even though exams are never the funniest part, I know. If you have questions, don't hesitate to email me. I might answer directly if it's easy questions. I might take 1 or 2 days if it's more complex questions. And I might just wait a couple of days if it looks like I get a lot of the same questions, and then I might do a general information. If no, I'm looking forward to seeing your data science project on the 1st of December. I hope you've learned something during class. I hope you have had a starting point to keep learning on your own from this. And again, I hope that I've done my best to try to keep it as practical as possible. So when you finish here, when you finish the examination, hopefully you should be able to actually do some easy data science project in an applied setting. Okay, if there is no questions, then I will just stop the recording.